Hello, welcome to Valve channel, I'm Stephen. Valve links are very important design factor when we're going to design a valve. Because when the user going to use the valve in the flow control system, if the old one have some problem or this valve is leaked, we need a new one to instead. Even though two valves designed in different manufacturing or made in different manufacturing, but two valves must have exactly same valve links. That can make two valves exchangeable. So in valve industry, we have a standard for this design factor. The standard called ASME B16.10. The name is face-to-face and end-to-end dimension of valves. So in this video, we are talking about how to use this standard to find the correct valve links for design a valve. Before we're talking about how to use this standard to find out the correct design factor for designing a valve, we need to understand the standard name first. The standard name called face-to-face and end-to-end dimensions of valves. The question is, what is face-to-face and what is end-to-end? Why this standard use two groups to describe the valve links? And what is the relationship between two groups? That is the first thing we need to understand before we use this standard to find out the design factor. According to the description, we have two kinds of flange valve dimension. One is called a face-to-face flange valve dimension, and another called an end-to-end flange valve dimension. Face-to-face means the valve extreme end, which are the gasket contactor surface. So that means the flange extreme end we're going to contact with the gasket. According to the flange standard ASME B16.5, we have four kinds of flange. We are going to contact with the gasket. Use the flange extreme end area. For example, the raised face. Raised face, we are going to contact with the gasket from this area. And also this area is the extreme end of the flange, or extreme end of the valve. And also the flat face, the principle is the same. We'll use the extreme end to contact with the gasket. The TG connection, tongue face, will use the extreme end to contact with the gasket. And also the MF connection male face will use the extreme end to contact with the gasket. So these four kinds of flange belong to the face-to-face valve flange dimension group. According to the standard, we have four kinds of flange face. One, flat face, raised face, male face, and tongue face. So these four kinds of flange belong to the face-to-face valve dimension. And another group called end-to-end flange valve dimension. According to the description, that means the gasket contact surface are not located at the extreme end of the valve. So according to the standard ASME B16.5, the gasket contact area are not the extreme end of the valve or of the flange. For example, the TG face, the groove face. The groove face, the area going to contact with the gasket will be the groove area. But groove area are not the extreme end of this flange. This area is the extreme end of this flange. And also the MF connection female face. Female face we're going to contact with the gasket in this step. The extreme end area is this area. So the gasket contactor area are not the extreme end area. And also the RJ face, the principle is the same. We have three kinds of flange belong to the end-to-end flange valve dimension. According to the standard, we have three kinds of flange: ring joint face, female face, and groove face. So now we understand what is face-to-face, how many different flange belong to the face-to-face group, and what is end-to-end, and how many flange design belong to the end-to-end flange valve dimension. But now the question is, why this standard divide two kinds of group of flange valve dimension? And also, what is the relationship between two kinds of flange valve dimension? That is the question we're talking about next. To understand why the standard divide to two groups of flange valve dimension, one is called a face-to-face and another called an end-to-end, we need to understand what will happen when we're going to design a flow control system. Like this picture, the first length we're going to determine is the pipeline length. For example, we want this flow control system, the pipeline length from this point to there is 300 inch long. And then we divide 300 inch to three parts, two pipe and one valve. Each pipe long 100 inch, and the valve length is 100 inch long. And then we use raised face flange to connect each part together. And then we add the lengths together. We can get 300 inch for the pipeline length. But the problem is, we can get 300 inch pipeline length from raised face flange connection. If we change the flange from raised face to MF connection face, what will happen? For example, we're going to use the female face for the valve, the male face for the pipe. We still maintain the pipe length is 100 inch. We still maintain the valve length is 100 inch. Do you think in this condition we connect three parts together, we still can get 300 inch long pipeline length? That is impossible. Because the valve, we are going to use the female face. The female face, the connection, the extreme area are not going to touch the pipe flange male face. The real area going to contact with the male face is the step area, is this area. So when you're going to use this flange design for the valve, but the valve still is 100 inch, when you add three parts together, the real pipeline length will be shorter than 300 inch. So if you still want to get 300 inch, you must make this valve a little bit longer than when the valve use raised face flange. So that is the reason why we have two groups of valve flange dimension. One is called a face-to-face, and another is called end-to-end. End-to-end must be longer than the face-to-face because we want to maintain the pipeline lengths are not changed, whatever what kind of flange you're going to use. So that is the reason why we have two groups of flange valve dimension. So next, let's talk about what is the relationship between face-to-face and end-to-end. The relationship between two kinds of flange valve dimension, face-to-face and end-to-end, already shown in this table, ASME B16.10, table 10. For example, when you're going to design a valve which is 300 pressure class, gate valve, the valve size is 4 inch. The valve length will be 12 inch long, according to the standard ASME B16.10. But this 12 inch just for the valve which going to use flat face or raised face flange. But this valve going to use male face or tongue face, you need to add 0.5 inch long to 12 inch. So if the valve, the flange is male face, the valve length is 12.5 inch long. And also if the valve use groove face to design, you need to add 0.38 to 12 inch. So the valve length will be 12.38 inch long for this kind of gate valve, which is 300 pressure class 4 inch. Because in ASME B16.10, the face-to-face and end-to-end, all design factors are all located in one table. And also, all those design factors just for the flat face and the raised face. If you want to know what is the correct design factor for other kind of flange face, you need to calculate from this table 10 in ASME B16.10. So next, I will give you 3 examples to show how to use the ASME B16.10 to find out the correct design factor for the valve length. The first one is a gate valve body. This gate valve is 10 inch, 115 pressure class gate valve. This gate valve body uses raised face for the flange connection. So raised face flange connection, we can directly use the valve length table located in ASME B16.10. According to the correct product class table, class 115, first vertical side is for the gate valve, and the size is 10 inch. We can get the design factor for the valve length, which is 13 inch long, transferred to millimeter, which equal 313.2 millimeter. So this blueprint designed by ASME B16.10, the valve length is approximate to 313 millimeter. So this blueprint is designed by ASME B16.10. Next one is a global valve. This global valve is 4-inch 300 pressure class. It uses raised face for the valve flange connection. Because it is raised face, so we can directly use the table in ASME B16.10. 300 pressure class, valve length table. Valve size 4-inch. Valve tape global valve. So this valve, the design factor for the valve length is 14 inch. Transfer to millimeter is 355.6 millimeter. So this blueprint are designed by ASME B16.10. The valve length approximate to 356. That is correct. The last one is 4-inch 900 pressure class ball valve. This ball valve uses RGF face for the connection. Before we already talked about, if the flange are not flat face or raised face, we cannot directly find the valve length from the ASME B16.10. We need to calculate the valve length from the ASME B16.10 according to the table 10. Here is the table 10 we already talked about. We will find the correct valve length from the calculation for different valve face, valve flange face. We talk about this ball valve is RGF face. So the RGF face described in note 8. In note 8, it already taught us we need to find the X dimension. The X dimension located in table 11. And then we add this dimension to the raised face, flange face-to-face dimension. And then we can get the correct valve length from this standard. So let's look at the table 11. Here is the table 11. In this table, you will find the X dimension for different pressure, different size valve. The ball valve is 4-inch. The pressure is 900 pressure class. So the X equal 0.12 inch. That equal approximate to 3 millimeter. Approximate to 3 millimeter. And then we add this 3 millimeter to the raised face flange valve length. According to the ASME B16.10, the 900 pressure class valve length table, all these factors are for the raised face flange valve length. The ball valve are located here, 4-inch. If you're going to design a valve which is 4-inch, 900 pressure class, if the ball valve flange is raised face, the valve length is 18 inch long. That equal 457.2. But now we're going to design a valve which is going to use the RGF face. So we need to add approximate to 3 millimeter to this dimension. So that equal 460. Approximate to 460. So that is the valve length coming from 460. So that is the basic principle how to use the ASME B16.10 to find out the correct valve length for our design. I hope you already understand. Thank you for watching. See you next video. Bye bye.